All right, we're going to be looking at solving basic linear equations. So for our first linear equation here, we have 2x minus 3 equals negative 5. So the goal here is to get x by itself. To get x by itself, we'll have to get rid of the 2 and the minus 3. As a rule, what you get rid of first is the number that is not connected to the variable. So in this case here, the number that's not connected to our letter x here. So that means I need to move the minus 3 first. To move the minus 3, we have to add 3 to both sides of the equation. That'll give us 2x equals negative 5 plus 3. We now simplify the right-hand side of the equation. Negative 5 plus 3 is negative 2. Now we're down to one-step equation here. We need to solve for x. That 2 is in the way. The operation between the 2 and the x is multiplication. So to undo multiplication, we do division. Divide across by 2, both sides of the equation. This will reduce to become a 1, so typically people won't write it. They'll just put the x down. You can put 1x, it's not wrong, but normally people just write the x. So that'll reduce to become x, and then on the right-hand side, we have negative 2 divided by 2 is negative 1. And we found the value of x that satisfies this equation. What that means is if I were to substitute in for x, substitute that with a minus 1, the left-hand side and right-hand side of the equations would be equal. Let's take a look at another example. In the next example here, same idea. We want to get rid of the 5 and the minus 4. Again, the same rule applies. You want to get rid of the minus 4 first because that 5 is connected to our variable here. So to move that minus 4, we're going to have to add 4 to both sides of the equation. That'll give us x divided by 5 equals negative 3 plus 4. Simplifying the right-hand side, we get 1. Now, once again, I want to get x by itself. The 5 is in the way. Now the operation between the x and the 5 is division. So to undo that, we have to multiply across by 5. Notice I put brackets around the number I'm multiplying by. That just makes it a little more clear here. You don't want to get this confused and think this is a 15. So by putting brackets around, you're telling yourself and who's ever reading this that you're doing multiplication. This will reduce to become a 1. So this just becomes x, and 1 times 5 is equal to 5. And we have our next solution. Let's take a look at another example. For the next example here, we have negative 5x minus 4 equals 11. Again, we want to get rid of the negative 4 and the minus 5. We're going to take care of that minus 4 first, so add 4 to both sides of the equation, giving us negative 5x equals 11 plus 4, in which case we simplify, we get 15 on the right-hand side. Now the operation between the negative 5 and x is multiplication. To undo that, we divide across by negative 5. Once again, we get our reduction. We get x equals 15 divided by negative 5 is in fact negative 3. And we have our next solution. Let's look at another example. For the next example here, same idea. We want to get rid of the minus 3 and the positive 4. We're going to get rid of the positive 4 first, as that's not connected to the variable, so we're going to have to subtract 4 on both sides, giving us x divided by negative 3 is 4 minus 4. Simplifying, we get x divided by negative 3 is 0. Now again, I want to get rid of that minus 3. The operation between the x and the minus 3 is division, so multiply across by minus 3. These will reduce, and we end up getting here x equals 0 times negative 3 is 0. Let's look at another. For this example here, now you'll notice there's nothing connected to the x. There actually is a 1 in front, but again, we're not looking to eliminate that. We want to get rid of this half here. So I'm going to go ahead and subtract a half on both sides of the equation, giving us x equals 3 minus a half. So really, we just need to simplify this and have our answer. We have an integer subtracted by a rational number here. So what we're going to do is we're going to go ahead and put that 3 over 1. And then we're going to go ahead and get a common denominator. So I'm going to multiply top and bottom of this expression by 2 so that we can get a common denominator. This becomes 6 over 2 minus a half, and therefore 6 over 2 minus a half. Whenever you're subtracting fractions, if the denominators are the same, you just subtract up the top here. So this becomes 5 over 2, and we have our answer. Let's look at another example. In this example here, we want to get rid of the minus 2, and there's actually a minus 1 in front that we want to get rid of. So once again, we're going to have to get rid of that minus 2 first. That's going to be negative 10 plus 2. Simplifying the right-hand side, we get negative 8. Now again, that number in front is actually a -1, so we're going to divide across by -1. This will reduce to become x again, and then -8 divided by -1 is +8. In our final example here, we want to get rid of the 2, the 3, and the +4 here. Once again, these are connected to the variable, so we're going to go ahead and take care of the +4 first, which means we're going to subtract 4 on both sides of the equation, giving us 2x over 3 is 6 minus 4, which becomes, simplifying the right-hand side, 2x over 3 equals 2. Now we want to get rid of the 2 and the 3. Typically, when you're in a situation where you have to get rid of multiplication between the variable and division between the variable, you always get rid of the denominator first. You always want to get rid of fractions. So we're going to go ahead and we're going to multiply across by 3 here. So that'll be multiplied by 3, multiplied by 3. This will reduce. 3 divided by 3 is 1. And now this simplifies to become 2x equals 6. And now the operation between the 2 and the x is multiplication, so we undo that with division, and simplifying we get x equals 3. All right, this was just a basic introduction to solving linear equations. Thank you.